All right. 75 attendees. Kubernetes security definitely is a hot topic. Welcome everyone to today's webinar, Securing Your Kubernetes Clusters, Part 1, How to Avoid Attacks. My name is Chrissy from Kubernetes, and I'm really excited that so many of you have joined today and are still joining. We are at 77 now. This is really great. In today's webinar, I'll have my colleague and our Kubernetes trainer Hubert with me, and he will cover Kubernetes security best practices and introduce you to security tooling that will help you keep your cluster safe. The second part of the series will take place tomorrow at exactly the same time, and the topic will be how to proactively prevent attacks. If you want to join us or get the recording of the second part and have not registered yet, I will post the link, the registration link in the chat so you can still register. Apart from that, if you have questions on Hubert's presentation, please just type them into the chat window or the Q&A section, and we will either answer them live during the talk or then in the Q&A session at the very end of this webinar. Also, in case that you need to drop out early, no worries, this meeting is recorded and we will send it to all of you in the coming days. And with this, I already want to hand over to Hubert. I'm happy that we have so many people here, and I hope you enjoy the webinar. Hubert, the stage is yours.
Thanks a lot, Chrissy, and thank you for your warm welcome. As Chrissy already mentioned, if you have any questions, please post them in the QA section. We can do it live. So during the talk, we can also discuss stuff after the slides and demos. So today's topic is securing your Kubernetes clusters. As Chrissy already mentioned, tomorrow is the second part where we take a look at some tools which help you on securing your Kubernetes clusters. So, oh, wrong window. I'll keep this on screen for a second. Imagine the following. You are responsible for the security for of your Kubernetes cluster and your organizations. If this is a good idea from the organizational point of view, that's another question. And you are doing that, what this guy is doing with the tires. And guess what? Management loves you because you perform and they have no clue if it's really safe or not. It's also not their job to know if it's safe. And then the following happens. You go into the office, grab a coffee, open your laptop, and take a look at the mails, close mails again, and open the browser to read tech news. And guess what? You are famous now. Typically, you don't want this kind of thing. And these are real screenshots of things that happened in the Kubernetes world where some people, did, for example, Bitcoining on Kubernetes clusters and stuff like that. And the management now is maybe not so happy anymore and looks like these guys. And the thing I want to give you with this short story is be solid as a rock. If you are responsible for Kubernetes security, you have to be solid as a rock, no matter if the management likes or not likes your estimates, no matter if the devs do not like the fact that they play a big role in the security topic. Yeah, it's a tough job. Before we start with the security, a short info about me, that you know who is talking to you. I'm Hubert, I'm from Austria. I'm doing Kubernetes stuff since 3 years at Kubernetes. Before doing that, I was 12 years of a software developer and was also responsible for some infrastructure stuff, so infrastructure architect. I like to talk tech, and you can find me on meetups and conferences. I'm a Linux Foundation trainer for CKA and CKD, and I also contributed some questions to the CKA. Yeah, and the main topic at Kubernetes is training. Yeah, also doing some consulting from time to time. Yes, and you find my Twitter handle and my GitHub handle and my blog on this page. Let's talk a little bit about Kubernetes architecture to understand afterwards what we are doing here. And teaser, yes, in this webinar, I will do a lot of live stuff. So we will play around with the Kubernetes cluster. I hope everything works out. So yeah, let's see this. Let's talk about Kubernetes architecture. What are the main Kubernetes components? Most of you probably know that. In the Kubernetes world, we have to distinguish between master nodes and worker nodes. Master nodes, the control plane of Kubernetes is running on the master nodes, and your applications are running on the worker nodes. And you see also some laptop on this image. Yeah, that is you talking to a Kubernetes cluster. So what are the components? etcd, the database. The whole state of Kubernetes is stored in etcd, which is a key value store. And the only component which is allowed to talk to etcd is the API server. It's a very important component, and we will talk later a lot about the API server because, yeah, it's a very important component. Then there's something which is called the Cloud Controller Manager, which allows you to get load balancers, disks, and maybe some nodes from the surrounding cloud you are running your Kubernetes cluster. The scheduler making the decisions. So depending on your resource requests and limits and some other stuff, the scheduler will hopefully make some smart decisions where to run your applications on which worker nodes. The controller manager. Kubernetes consists of a lot of endless loops, aka reconciliation loops. And these reconciliation loops are managed by the controller manager in the end. Not all of them, because some reconciliation loops are also running outside the controller manager. The scheduler, for example, is also a reconciliation loop. Let's switch to the worker node. There is a container runtime. Yeah, Docker, container D, cryo. Then there's the kubelet. The kubelet is running on the worker node, and he knows which containers have to be started at this specific worker node, basically. And the kube proxy is dealing with networking. So if you want to expose your applications internally or even externally, the kube proxy plays an important role. He implements all those rules via IP tables, basically. So if you apply a service to your Kubernetes cluster, kube proxy will change some IP tables on each and every worker node. And yeah, that's the role of kube proxy. From the communications point of view, API server is the only one which is allowed to talk to etcd. All the others are talking to the API server. Also the components of the worker nodes. So the kube proxy and the kubelet are talking to the API server. One thing which is interesting here is that the API server also talks to the kubelet from time to time. Examples for this would be getting logs or doing a kubectl exec. So these are situations where the API server wants to talk to the kubelet. And the kubelet is also talking to the container runtime to start and stop containers and also to monitor the containers in the end. And we are also talking to the API server. So if you are connected to a Kubernetes cluster, you are talking basically to the API server or maybe to a load balancer which stands in front of the API server, which is manifested in the home directory in the .kube config file. All the stuff is in there on your machine. One note, etcd can also run outside the master nodes. etcd is not part of the Kubernetes project. It has its own release cycle. And for sure, you can also run etcd outside the master nodes. This is a very simplistic visualization. For sure, in reality, it looks more like this. So you have more than one master nodes and more than one worker nodes. Yeah, typically you have 3, 5, or 7 master nodes. More than that doesn't make that much sense because it slows down at the CD in the end because it has to keep sync. Yeah, and typically you also have more than one worker nodes. One thing I didn't mention was the CNI plugin. It's not part of the Kubernetes project. Kubernetes only provides an abstraction, so an interface. The CNI plugin providers like Cilium, Fennel, Kennel, and so on have to implement this. And it's needed for the communication between the worker nodes. So in Kubernetes, each container running on a worker node should be able to talk to each container running on another worker node. And that's basically the job of the CNI plugin to ensure that pod A can talk to pod B no matter on which worker node it's running. Now, a few words to the installation base, because I think it's important to understand later for the labs what we are doing here. Some of you probably know the famous Git repo Kubernetes the hardware from Kelsey Hightower, and that's a Git repo where you can set up a Kubernetes cluster completely without any tool support. And what you're doing basically here is installing Kubernetes as Linux services, so the components of a Kubernetes cluster as Linux services. Here you see the kubelet, which gets deployed as a Linux service here. For sure, this is nothing you would do for production because this is a lot of manual work and this is, yeah, probably a lot of typos you could make. So we need some tooling support here for installing Kubernetes clusters. And we already have seen this. Yeah, it looks like this. Installation the smarter way. As already mentioned, we need some automation tool to install our Kubernetes clusters. And a lot of people are using tools like kubeadm or kube1. So yeah, there's a lot of automation base and you don't have to deal with a lot of the small things, for example, upgrading certificates or creation of certificates. This is all implemented in kubeadm or kube1. This is how you bootstrap a cluster with kubeadm. It's a very simplistic cluster for sure, but yeah, it's very straightforward. One thing which is important, that's important for the labs later on. If you work with kubeadm, you deploy the components of the Kubernetes cluster, so the control plane components, not as Linux services. They run as containers. So not all of them except one. The kubelet is still running as a Linux service. And the kubelet has configuration possibilities, and this you see on the screen. There is static pod path. And in this static pod path, you can create some pod manifests. So no deployments, no stateful sets, no cron jobs or whatever, only pods. And the kubelet will start those pods which are in the manifests directory. And if we install a Kubernetes cluster with kubeadm, you will get already 4 such static pod manifests: etcd, kube API server, kube controller manager, and kube scheduler. The kube API server, we will play a lot with it in the next 80 minutes, so counting also tomorrow in. And this looks now like that. So we have, again, master node, worker node. We have the kubelet still running as a Linux service. So this is still running as a Linux service, also on the worker node. And there's the container runtime also on the master node. And within this container runtime, for example, Docker, the controller manager, the scheduler, etcd, and API server are running as containers. And on the worker node side, the kube proxy is also running as a container. Now, installing Kubernetes like a boss. As we have seen, installing Kubernetes manually is a lot of work, and so we need some automation. So we decided to go with containers. So we used kubeadm to install our cluster, and the cluster components got started via static pod manifests. But you even can go further, and there's something which is called kubeception. And kubeception means you're running the control planes of your user Kubernetes clusters in a very specific Kubernetes cluster, which let's call it seed cluster, which means you run the control plane components also as clusters, but they are managed by Kubernetes itself. And this is exactly what we are doing at Kubernetes with KKP. And you will gain a lot of benefits. So the resource demands for user clusters will get decrease a lot, because you are not starting VMs on starting a new user cluster. You are only starting some containers in a Kubernetes cluster or some pods in a Kubernetes cluster. They start up way faster than VMs for sure, and you can use the whole greatness of Kubernetes, meaning liveness groups, readiness groups, rolling updates. Doing upgrades is very easy if you do it so, and so on. Okay, that's for the installation part. No, sorry, visualization I missed. So this is how this then looks. You have this magic seed cluster, you create some namespaces, and you create the control plane components in this namespace. And then you add some virtual machines to it, and you have a Kubernetes cluster. And you can do this multiple times. But now, to something completely different. Some of you may are old enough to know Monty Python. Before we start into the security topic, I want to tell you some Greek mythology story. How King Admin the Naive became King Admin the Proactive. Yeah, this is King Admin. King Admin is a very wise king, and he made already some smart decisions. So King Admin is the king of a kingdom, or a polis, like the Greeks like to say. And he has chosen Kubernetes for the structure of his kingdom. King Admin is a little bit naive, especially on the security things. But everybody loves him. So his kids love him, his dog loves him, and his wife loves him. Even his ex-wife loves him. And this is the policy he's responsible. This is a map of this beautiful Kubopolis. On the right side, you see the photo of King Admin. And you see some buildings. This should be buildings. And on the right side, there are 5 buildings which are called etcd, API Server Scheduler, Cloud Controller Manager, and Controller Manager. And they are connected via roads for sure. Because King Admin is a very wise king, he decided not to do farming or do smith's work in the main city. So he created some smaller cities. Let's call them worker nodes. And there are two worker nodes. So kubelet, kubeproxy, and the container runtime engine. These little boxes here, those are the workermen. So those are the smiths and the farmers which are doing stuff which the King Admin then can maybe sell to some other king. And the other king talks maybe via this road to this workerman. Okay. Each great story needs a villain. And in our case, this is Hakerios. And Hakerios will now try to do bad stuff with King Admin's Kubopolis. Before we start, the lab environment, as already mentioned, I used kubedm for setting up a Kubernetes cluster. So everything is running in containers except the kubelet. And also, this is a single node cluster for the sake of simplicity, meaning, yeah, also he's working as master and worker node at the same time. And let's check if it's running. Get pods. There's one pod running and get nodes. Okay, cool. Everything is running. So, chapter 1. Hakarios attacks basically everywhere. And this topic is about firewalls. It's maybe a trivial point, but a proper firewall is very important in the Kubernetes world. And if you take a look at our Kubernetes, you see here that Hakarios is somewhere in the middle, and he can access everything, and that's bad. And so King Admin has a great idea. He builds walls around the worker nodes and also around the master nodes. On this image, you see a beautiful wall, which has a hole. And we need these holes also in our firewall for reaching, for example, the API server. So we have to talk about ports in the Kubernetes world. The most important port is the API server port, which is running on 6443 by default, depending on your context. If you are running Kubernetes on-premise and you have a corporate network and which is safe, and the users of your Kubernetes clusters can reach the port 6443, everything is fine. If you have some remote workers, maybe via VPN, yeah, it's also the corporate network. This is also fine. If you are in a situation where you have to expose the Kubernetes class or the API server to the internet, yeah, you need a valid reason for doing that, because this can get very dangerous. The other parts of the control plane of the masternode components, you do not expose at all. Typically, nobody has to have access to etcd, for example. Maybe if you're doing backups, yes, you need access to etcd, but typically, yeah, this is not exposed to anywhere. The kubelet, typically you also do not expose to the outside world, and we will see this in the next lab, that this can get very dangerous if you expose the kubelet to the outside world. But this is also depending a lot on your topology. If your worker nodes are running somewhere spread across the globe, yeah, you have to make some considerations about how to ensure that the kubelet get not visited by evil persons. Yeah, kube scheduler and kube controller manager is not that. I do not know any valid reason why I should expose this at all. On the worker nodes, yeah, for sure you have the kubelet again, and the node ports, which the default IP range port range is 30,000 to 32,767. Depending on your ingress strategy, you typically also do not expose it to the outside world, because you have an ingress in place which handles this for you, or you're doing stuff via service mesh, for example. So, first chapter accomplished. Now we have these beautiful green firewalls around our cities. So the two worker nodes and the one master node. And Hakarios yeah, is set. Now Hakarios attacks the suburbs. And this chapter is about securing the worker nodes. For whatever reason, some evil guy has access to the worker node. But if you expose the kubelet to the outside world, this evil guy do not need access to the worker node, so he don't needs to SSH into the worker node. He can also do this from the outside, and we will see this in the lab exactly now. So now the fun begins. So I already told you we have here the one single node Kubernetes cluster, and if we do a get pods minus all, we see that a lot of Kubernetes components are running as pods themselves because of the static pod manifests, like the etcd, the APIs, and stuff like this. So now, due to the fact that some kubelet is exposed to the internet, somebody can probably do stuff like this. And one note I forgot to mention, I also stored some environment variables which makes my life easier. Now I do a curl to the kubelet. P on port 10,250, 10,250. And yeah, let's take a look. Oh, that's interesting. I get a lot of matrix data without authentication authorization. That's not good. So if you run some Prometheus stack, Prometheus could pull those metrics from the kubelet. But as we see, an outstanding person can also do that. And it even gets worse. Let's take a look at the log files. We get some HTML back, which looks very interesting. So let's dive a little bit deeper into it. We are interested in pods. And again, some HTML page. And now I want, for example, the etcd stuff. I want the logs of the etcd. And I have to add the container name and the log file name. And as you can see, I have all the logging from etcd available. If you expose kubelet to the internet, and if you do some misconfiguration of the kubelet, I will show you next. Before doing that, I want to show you even worse things if you don't care about this. But now I do some copy paste because otherwise I will do a lot of typos. Can we execute commands via reaching the kubelet? And the answer is, you guess it, yes, we can. So we do a post request again to the kubelet to default namespace to my suboptimal pod to the container my Ubuntu, and we send a command. In this case, we want some specific file. And this file holds all the users which are available at the host. And this is a big problem, for sure. Why is this doable? There are two reasons. The first one is, if you take a look at the, where am I? If you take a look at the pod, something very unsafe is done. We have a volume mount. So we mount the volume, so the root directory of the host into the container below the path host. And so everybody who can execute a command in a container can get all the details of the host, basically. So that's a very bad idea. That's the first reason why this was doable. But there's a second reason why this was doable. And for this, we have to look in the kubelet configuration. Kubelet config. And we have here authentication and authorization, and this looks suspicious. Let's change this in anonymous enabled false. Authentication done, and authorization always allow also sounds some kind of wrong. Let's change this to webhook. So now the API server gets asked for authorization in the end. Save it. Now we have to restart the kubelet. Kubelet service. Pull it running. Looks good. And now test it if we still have this security problem. We do the curl again. Unauthorized. Okay, cool. And that's the message of the story. Ensure that you have proper authorization and authentication enabled in your kubelets. And also ensure that, yeah, you probably have some corporate firewall, which doesn't allow you to access the kubelet at all. Back to the slides. Okay, so now the kubelet is also in a green box or circle. So the kubelet is also safe, but we still have a lot of work to do here. Now Hakarios tries to steal identities. And for this, we do not need access to kubelet at all. He can do that via having access to, yeah, to the containers in the end. And for sure, you have to provide access to your Kubernetes cluster only for persons which you trust, but sometimes, yeah, some consultants or other people also get access to your Kubernetes cluster. And now it can get dangerous. In Kubernetes, each pod by default holds its security account token and also the certification authority file. And this is shown here with these keys. So each pod has its sensitive data mounted into a specific directory. And Hakarios now tries to use that. Before playing around in the labs, some notes about authorization in general. You can customize this in the API server, how Kubernetes does authentication authorization. If you're talking about authorization, yeah, node is needed for allowing worker nodes to join in the end. ABAC is not used anymore, really, because RBAC is now used most of the time, and it's already the default, and you can also do webhooks for sure. This is how you define which authorization modes are in use. Typically, you have something like Node and ABAC. This, I see this a lot. So what is ABAC? ABAC stands for Role-Based Access Control. So we can define some roles and assign them to users or applications. So the first thing we have to do is creating a cluster role or a role. Cluster role is for the whole cluster and role is for a specific namespace. And then we add to this role some rules. And the rule can be, for example, get list watch pods. So it's very fine granular. You can define a lot of rules. So yeah, for example, getting pods, listing pods and watching pods. So how to give this role to a user or an application? That's the next question. Yeah, user and application. If we're talking about applications, we're talking about service accounts. So the service account gets added to the pod manifest or deployment manifest, and then the application running in the pod has the depending roles. But something is missing here. the missing link, cluster role binding and role binding. Again, cluster role binding is for the whole cluster and role binding is for a specific namespace. And this links those two roles basically. So yeah, so you can link a user to a specific role, or you can link a specific application to a specific role. Let's play around a little. So I have to open my cheat sheet. So let's verify if it's really the case that we can get very sensitive data from each and every pod. And yes, we can do this. So we exec into my suboptimal pod. Bye. Let's change this. Okay, let's exec and my suboptimal pod and print out some specific file. It's below var run secrets kubernetes.io service account token. And we get it. That's the service account token, which is mounted into the container in the end. And we can also do the same with the certification authority, and we get everything here. Okay, let's use those and store it to somewhere. So first of all, I create an environment variable holding the token. And second, I store the certification authority in this file. And that's the trick. As soon as you have this, you can talk to the API server. Let's try this. So I'm doing a curl again. But this time, I'm not sending the request to the kubelet, I'm sending it to the API server. And I'm using the token, and I'm using the certification authority file. So, and I'm here asking Kubernetes, give me all the pods in the default namespace. And I get it. And this is also not very nice, to be honest. And one reason why this is doable is because we have a very suboptimal cluster role binding. So let's check the cluster role bindings. Role bindings. And here's the suboptimal cluster role binding, which basically binds the cluster admin role to this my suboptimal pod in the end. So let's change this. I simply deleting the cluster role binding. Suboptimal cluster role binding. Okay. And now let's do a curl again. And now I get the forbidden. So, moral of the story, be careful with your roles which you assign to namespaces or pods, so service accounts in the end. Because if somebody steals the token and the certification authority, somebody can talk to the API server. And now there's one additional catch here. I will come in the slides. One thing I want to show here is how you can configure all that stuff. Manifests. This is now the static manifest of the API server. And you can see here, yeah, we have node and ABAC. That's fine. Back to the slides. I already teased this. There is a flag which is called automount service account token. And if you set that to false, the service account token will not get mounted in in this specific pod. And most of the time, your applications do not have the need to talk to the API server. So I think most of the time you can set this flag to false in your pods, which means that the token is not in the pod, and so nobody can steal it. So the secrets are gone in the pods here, because the automount service account token was set to false. And now Hakerios is again set. Now we start the big topic of encryption. And we will not finish this today because it's a huge topic. So I will start it today, but yeah, we will have to talk about this also tomorrow. If you're talking about encryption, we have to talk about 3 different levels of data. So encryption at rest, meaning when it's stored, for example, in etcd. Encryption in transport, which means over the line. So here, here, and here. And encryption at usage, which means when the application is using some sensitive data. Yeah, encryption at rest, in transit, and in use. Let's talk first about at usage. And if your application running in a pod needs some sensitive data, because it's a web server, and the web server wants to talk to some database, and it needs the database credentials for sure, then you mount this into the containers in the end. So you have the data in the containers, the sensitive data. One side note here, if you're working with Kubernetes, you have probably a lot of YAML files. Now the question is, where do you store those YAML files? Probably in a Git repo. So you also have the credential data in a Git repo, probably. And yeah, due to the fact that secrets are not encrypted, they are only encoded, this isn't safe at all. So also for this, you will need something like a Git crypt or Mozilla SOAPs, which allows you to store, for example, secrets in your Git repo. So let's talk about secrets first. Secrets are not encrypted. They are only base64 encoded, and we will see this afterwards in the labs. That's the bad news. The good news is all the secrets are not stored at the persistent disk at all. They are in a temp file system. So a secret will never touch a disk, and that's a very good idea. And within the bots, the secrets are decrypted for sure. But yeah, decoded. This is wrong. I have to fix this. They are decoded because there is no encryption at all. And this makes sense because the applications expect, for example, the database password to be in plain text. Let's play around with it. So let's create a secret. Create secret. My password. No, my secret. From literal password equals password 1, 2, 3, very secure. And the secret got created. And yeah, we can take a look at the secret. So kubectl get secret my secret. And if we do a -o YAML, we get this here, and this is encoded, not encrypted. That's the important part here. So let's decode that stuff. So if we do a JSON path, data password. we get the part of the password itself, base64 encoded. And now let's do a base64-d. And we have it in plain text. Okay, so yeah, no encryption. Let's use it in the pod. And here we have the volume mount and the volume itself. And let's apply it, and I have to force it, I think. So the secret now is mounted in the pod, hopefully. That's running. It's 6 seconds. Okay, cool. So let's check what is going on inside the pod. And we mounted it to secrets folder. And we see here some interesting file, which is called password. So let's check it. Secret password. And you see, yeah, as mentioned, the secret is in plain text inside the container. Okay, how does this look on the on host level? Do we also have the secret in plain text? And the answer is yes, we have. We have to take a look at the temp file systems. And I think this one looks interesting. And let's cut this. I think password. You see also on host level, you see the password in plain text. Yeah, this is how it is. Let's say it like this. I will talk tomorrow also a little bit about how we can use HashiCorp Vault or other tools to make this secret stack a little bit more secret or encrypted. But this is it now for encryption usage. The last topic I want to cover today is, maybe I think I will stop it here because I'm running out of time. So I will start with encryption at transport tomorrow. And because I also want to be able to answer some questions of you. Yeah, Hakarius is said, but King Admin doesn't care. There are a lot of topics we want to cover tomorrow. And to give you a small teaser, yeah, we have to talk about encryption at transport, as already mentioned. We will talk about encryption at rest. We will talk about encryption in the backups, because this is a very special topic. Then we will start to use tools. So we are getting proactive, and we are doing static manifest scanning. In our case, via KubeSec. Image scanning via Travi. Then we do some admission control via Kyverno. We also take a look at host level security with Armor. Kubernetes auditing, how to enable this. Threat detection via Falco. And last but not least, we do some benchmarking of our Kubernetes cluster. And again, this will be a lot. So tomorrow it even will be more live demos, because we will want to try basically everything from this list. Okay, then maybe let's start with some questions. I hope I can answer some of them.
Are there questions? Everybody is shy, or you answered them already all. No questions? All right. If there are no questions, I mean, if there are questions, you can still reach out to Hubert via Twitter. Now I see one coming. Are the default install settings bad?
Depending on which tool you use. So the first thing I showed you with the kubelet, where you didn't need to authorize and authenticate yourself, this is not the default. So I changed the default. So in general, if you're using a Kubernetes offering by some public cloud vendor, those things should be ensured that there's no problem. If you're doing it on your own, you have to take care about this. But if you're using KubeADM, for example, this kubelet is not available to the outside, so you have to authorize yourself, for example.
More questions? Okay, as I said, if you have questions like popping up later today, then you can still reach out to Hubert via Twitter. You can see the handle on the slide, or via email at via hubert@kubernetes.com. Yeah, thanks all for joining. One more question.
Yeah.
But we also have a couple of minutes left. Do we need to secure kubelet on EKS?
I'm not sure about this. I have limited knowledge about EKS. EKS or AKS? That's the question.
EKS. So
EKS. Okay. Okay. So
AWS EKS.
AWS. Okay.
Yeah.
So in AWS, as far as I know, at least this is my knowledge, and this is maybe outdated knowledge, you have to manage the worker nodes on your own. But I would be surprised if AWS doesn't take care about this. So I would do simply the test. Can you reach the kubelet? Typically, it's running on port 10.250, and take a look at the kubelet config. And I would be surprised if they do not care about this. So it should be the authentication and the authorization should be safe. But I'm no expert for AWS Kubernetes, to be honest. So take a look at the kubelet config.
All right. Then, if we have no more question, thanks Hubert, thanks everyone for joining, and maybe you can just go to the next slide. Yeah. I already typed it twice in the chat. Tomorrow we have the second part. Hubert already presented like what topics will be covered. If you want to make sure to like have access to the live session or get a recording after the event, please make sure to register. You find a link in the chat. You can also find it on our website. And then if we jump to the next slide after that, so I would want to like draw your attention to Container Days, which is going to take place on September 5 to 7th in Hamburg and online. And it's a super nice festival, like very laid back conference. We have many exciting speakers in the ALIA from Isovalent, from CERN, from Audi, from NetApp, from Container Solutions. So you will have like a lot of people that you can learn from. And it will also be your opportunity to meet Hubert in person and go in even more depth with his workshop Lines of Defense, Securing New Kubernetes Clusters. The online participation for this event is for free, of course. And if you want to join our on-site conference, which I can like highly recommend, Hubert has a special gift for you. So if you contact him, then you can get a 50% discount on the official ticket price. I will post the website link in the chat. You, of course, can also find the information on the conference on our website. And with that, I want to end this webinar. I want to thank you again for joining. If you like what we are doing, we are always happy if you follow us on Twitter, or if you check out our open source projects on GitHub, and if you like them, leave us a star. And then I just hope I see many of you again tomorrow for the second part of this session. Thanks again, Hubert, and enjoy the rest of your day. Bye.
See ya. Thanks, Chrissy. Bye.